Welcome back, listeners, to another episode of Shooting Rabbits in a Barrel, a podcast brought to you by Scarecrow Consultants. I'm joined today by Joy. Hi, Joy.
Hi.
How are you?
Yeah, I'm good. Thank you for having me today.
Thank you so much for coming. So we met at last year's ASEC, the annual Systems Engineering Conference in the UK, where you were giving a tutorial I was in with your new business, OptimiSE. Could you tell us
Yeah.
a little bit about that?
Yeah, sure. So I founded OptimiSE last year. I am an independent consultant for OptimiSE, providing services to organizations hoping to leverage the power of multidisciplinary design optimization, or MDO, also integrated with model-based systems engineering, MBSE. I also have another OptimiSE Academy where I record a lot of courses, hoping to give people a chance to learn about these topics and do it themselves.
Amazing. We love to see it. MBSE hype. Yeah.
Yeah, that's great.
Yeah. Cool. So thank you so much for joining us on Shooting Rabbits. We
Yeah.
have two questions that we ask
Mm,
every guest. What story would you like to share with us today, and what valuable lesson did you learn? So,
mm.
Joy, what
Yeah.
story would you like to share with us today?
Yeah, sure. So the story that I wanted to share today is actually the founding story of OptimiSE. So yeah, again, back to this topic, but some background to this story. This is a story when I worked at one of my previous companies, and at that time we were developing an aircraft which was designed for operations in several urban and regional regions. At first glance, we had a very promising product, but then came a very critical business goal. We needed to make the aircraft viable in a market with very extreme environmental conditions, a very high density altitude region. And for those less familiar, high density altitude regions, they are often found in very high altitude areas with very warm climates. And this creates very thin air, and that dramatically reduces the aircraft's performance. Everything from the engine thrust to lift generation is compromised. It's like asking the aircraft to operate in an environment where it constantly feels underpowered. So this often necessitates reducing the payload to counter the effects of diminished lift and propulsion efficiency. By lowering the aircraft's total weight, we ensure that it can still take off, maintain altitude, and also avoid overstraining the propulsion systems. But the payload we could carry directly affected the profitability. If we reduce the payload too much, we wouldn't be able to carry enough passengers or cargo to make the operations economically viable. So we were kind of stuck. How could we design an aircraft with enough performance to sustain profitable operations so that it remained attractive to operators in those very challenging environments? And recognizing the potential of multidisciplinary design optimization, I then proposed and led the adoption of it as a core approach to address the design challenges. MDO really played a very pivotal role by optimizing the aircraft design, particularly minimizing the aircraft's empty weight. It frees up the capacity and reduces the impact of payload restrictions. So by then, even if payloads were reduced, because we have such a minimal empty weight, we ensured the aircraft remained economically viable, and we were able to preserve the profitability targets. And that's basically how MDO was used, and really where the beauty of MDO really shines. MDO is all about optimizing design variables from multiple disciplines at once, like aerodynamics, propulsions, structures, and many more, and to find the optimal balance between all of them. And we didn't focus on any one discipline, but instead we looked at how they all interacted from like material choices or structural design, power requirements or missions, aerodynamics, they were all on the table. Through MDO, we could explore how adjustments to one aspect might ripple through the system and affect the others. We used a lot of domain models that capture the kind of the key performance metrics in different domains under the different operating conditions, and we iteratively explore the different design configurations. The goal was to make the aircraft as light and efficient as possible without sacrificing any safety or key operational capabilities. For example, we investigated structural design optimizations, adjusted different propulsion strategies, and we tested different materials that kind of balance the weight savings with durability. And the process allowed us to uncover design configurations that weren't obvious at first glance, those configurations that wouldn't have been possible to discover without this holistic product level approach of MDO. And after several rounds of optimization, we achieved something quite remarkable, I think. The aircraft was finally light enough to carry a profitable payload, even in those very challenging conditions we wanted to penetrate into. And to me, this wasn't just about meeting engineering requirements. It was more about unlocking an entire business case, an entire market. Because with this new design, we could transport enough passengers or cargo to meet the profitability targets and successfully enter this high density altitude market. And this region, which was previously considered off limits because of the performance concerns, became finally a viable and profitable operating environment for our operators. So that was the story.
Wow, that's so exciting.
Thank you.
I will ask you the question in a minute, but I think it's what you've just explained. It's a really helpful tool for us to do what we need to do as systems engineers, which is consider all these different characteristics to balance them, to have the trade-offs, to have those technical negotiations, if you like.
Exactly.
Very exciting. Okay, so Joy, what valuable lesson did you learn from that experience?
Yeah, I think tying back to what you've said, I think the biggest lesson for me is that I learned MDO isn't just an engineering tool. It's really a kind of a strategic tool. It helps bridge the gap between technical feasibility and also business viability. I think in aerospace and many other industries as well, you're not just optimizing for performance. You're really optimizing for success in the market. And that's why this realization led me to found OptimiSE. Another key takeaway to me is the importance of cross-disciplinary collaboration. MDO forces you to bring together different teams, whether they are aerodynamics, propulsion structures, or business strategy, or even commercial team or the C-level executives. And it ensures everyone is aligned on this holistic goal that you have to define before you start MDO. Without that synergy, this success wouldn't have been possible. And that's the two lessons learned.
The two lessons, love it. Thank you so much, Joy. Yeah, it's a massive part of our role as systems engineers to get people to talk to each other. But I think sometimes without that push of this is how we're doing our engineering, so you have to engage, it can be really difficult to get people to participate, I think.
Definitely,
Yeah, so having something like this that's part of the method of what you're using. And I've seen some of what you do, and it looks great. It's really cool, and I think it looks technical. Like, whereas I think with some of the systems engineering stuff we do, like writing requirements or doing this, like people go, oh, if they're a real mechanical design engineer head, they're like, oh, I don't really want to do that. Oh, that doesn't really look like it's to do with me. But I think it looks like no, we're really looking at the technicalities, the mechanics of the system, and what it really needs to be able to do to perform. Just think it makes it more appealing for people.
Yeah, definitely. I think MDO is for a long time has been perceived as something very academic, something for research labs, or something only preserved for very high technology or very complex systems, only. But I think my hope is that more engineers and systems engineers can see it as an accessible methodology. It's very mature, and there are a lot of tools available. You can do it, using Python only, and really this is something I think is very ripe for systems engineers and systems engineering, to take on, to absorb this, technical or not too technical, perhaps, kind of, activity.
Epic. Well, I'm excited to see where this goes. I can't wait to see where your business goes, and all the different things that you services that you're going to start providing. Thank you so much for joining us and sharing your story. It's been a delight to have you.
Thank you. It's been a pleasure.
Thanks. Cool. So listeners, if you'd like to get involved, you can contact us at rabbits@scarecrowconsultants.co.uk, and you too can come and be a guest and share about what you do, as Joy has done. But for now, we'll see you again next time. Bye.
Yeah. Thank you. Bye.
Bye.